Now let's work on part B of homework problem cp031 and 133. And again, we want to determine v sub x and I sub x. So here we have I sub x and here we have v sub x. And so we will try to find the easiest way to obtain these values. Now, when we do the analysis, in this case, if I look at this node, I know that I have a current that flows into this node, another current that is 6 amps that flows out of the node. So the only current that is not known is this one, and so I can write a Kirchhoff's current law that will be I sub A, that's the current coming in, plus 4 amps that are also coming in, will be equal to 6 amps as the current going out. So this current is going to be equal to 6 minus 4, 2 amps. Now this tells me then that if I have 2 amps flowing through this 3 ohm resistor by passive sign convention, that's 2 times 3, I have 6 volts positive on the right hand side, negative on the left hand side. Now the other voltage that I can find is voltage across these 2 ohms. Passive sign convention tell me that if the current enters the positive sign, so we don't know if we have a positive sign, but we're going to then use passive sign convention to assign this polarity to this resistor, and so that means that this is going to give us 8 volts across this resistor. Okay, I have now this value, and I will try to apply Kirchhoff's voltage law around this loop, or on the other way. So in order to do that, I need to know what's the current flowing to this 5 ohm resistor. Well, I know that I have 10 going this way, I have 4 going this way, so the only value that I don't have is this current over here. So I can write another Kirchhoff's current law number 2, where I know that I sub B is going to be equal to 10 amps going in this way plus the other 4 going the other way. So I know that I have 14 amps flowing through this 5 ohm resistor. Now again, I will apply passive sign convention, and I know that if this current is coming this way, then I will put a positive sign right here, negative sign over there, and now voltage here will be equal to 5 ohms times 14 amps, and that's going to be equal to 7. So I have 70 volts across this 5 ohm resistor. Okay, I have this value, this value, this value. I'm going to apply a Kirchhoff's voltage law around this loop, but I still need to know this value, and so now I know that I have 6 amps this way, and that I sub B was 14 going this way. So that means that in order to have 14 over here, applying Kirchhoff's voltage law, or I'm sorry, Kirchhoff's current law to that branch, will be equal to having a current coming this way. Since this is going to go this way, 6 amps, and this is going to be 14. The only way that this is going to be 14 is that I'm going to have actually 8 amps adding into this node to give us 14. But we can write these equations, and these equations, if I look at the direction of how I sub x is going, I can say, well, let me write this equation as current coming in equal, current coming in is 6 amps, equal to the currents that will go out, that's 14 amps, plus the I sub x that we have over there. So I sub x then becomes 6 minus 14 equal minus 8 amps. That means that the current actually is flowing in the other direction, as I've assumed before. Now these 8 ohms going in from right to left using passive sign convention will give me a voltage 8 volts with that polarity. So now I can apply Kirchhoff's voltage law around this loop, and I'm going to start right here. Kirchhoff's voltage law we'll start by writing minus v sub x The next value is plus 8 volts plus 70 volts plus 8 volts minus 6 volts equals 0. So if I send v sub x to the other side of the equation, then I have that this is going to be 8 plus 8 is 16 plus 70 minus 6 volts, and I can see that this is going to be 80 volts, and that will be the result. So we have 80 volts result for v sub x, and I sub x was minus 8 amps.